Welcome to Neon Math. Today, let's learn about inequalities, including solving and graphing. Inequalities. So, you've dealt with expressions being things like 3x squared or 3x plus 5. Those were expressions. If you think of math as a language, then maybe this was a word and this is a little phrase. As soon as we throw an equal sign in there, we could almost think of that as a sentence. With the equal sign, we have an equation. So we had expressions, we have equations. But today, I want to focus on inequalities. And what makes an inequality an inequality? Well, instead of an equal sign, we have other symbols that have different meaning. This is a symbol they told us is a less than symbol, a greater than symbol, a less than or equal to symbol, a greater than or equal to symbol. Now I want to let you know that this is only the less than symbol when we're reading left to right. So if we were reading x is less than 2, then yeah, it's a less than symbol. If we're reading right to left, if I wanted to talk about 2 and I was reading from right to left, then I would say 2 is greater than x. So when we are reading left to right, as if I'm reading from the variable, some people say, hey, this looks like an L. This less than looks like an L, so that helps me remember it. This one doesn't look like an L, so it must be greater than. Y is greater than -2. Over here, we have the less than and greater than symbols, but they throw an equal sign on there. And that just means, okay, so if x is less than or equal to 3, x could be equal to 3 or anything less than 3. 2.99 to -1, etc. If I had something like this, I could say, yes, 2 is greater than or equal to x. Nice. But if I read it, we call it backwards, x, now I encounter this small side first, the pointy side, the small side, and I know that's the less than side. X is less than or equal to 2. 2 is greater than or equal to x. So pretty simple if you just remember, if I'm approaching the large side, that's the greater than side. If I'm approaching the pointy side, that's the less than side, the small side. So if you think of it that way, it's pretty straightforward. Now, how we graph these, we have to put a point on the graph. The less than gets to be an open point on the graph. The greater than is an open point on the graph. Less than or equal to is a closed point. Greater than or equal to is also a closed point. So let's say x is greater than or equal to 3. All right, so when I graph, I like to throw my 0 on there, splitting my number line into positive land from here to infinity and negative land from here to infinity. 3 is definitely going to be in positive land. I'll throw a 3 on here. I should put a 1 and a 2 and a 4 so we know where we are, but I don't have time. X is greater than or equal to 3. I'm going to put a point here because there's an equal sign. It could be 3, so I'm going to fill that in. X could be 3 or anything greater than 3. And I popped this arrow out and over because it's easier to see. When I was young, they taught us to just put our arrow on the line, but it was harder to see that way. Same thing. So x is greater than or equal to 3. Let's just look at one that's backwards. 2 is less than y. I'm going to read this backwards, and y is greater than 2. So I'm going to come in here, and we're going to put a 2. And y is greater than. Why is it greater than? Because I'm approaching the large side. Y is greater than, open circle. 2, y is greater than 2. So it can be 2 or, sorry, it can't be 2 because it's greater than and it's an open circle, so it cannot be 2. So I don't include that point, but it can be anything greater than 2. All right? All right, let's do a couple problems. Let's solve and graph some inequalities. I'm going to treat these like equations. I want to isolate the variable. I want y by itself. So I'm going to solve this and then I'm going to graph it. So let's get this positive 3 out of here. And the opposite of adding 3 is subtracting 3. And here I have y is greater than, it's still greater than, 5 minus 3 is 2. Notice I didn't touch the sign, I left it alone. And if you're thinking, wait, I remember something about negatives and flipping. In another video, you will learn that if you ever multiply or divide by a negative, then you have to flip the inequality sign. But today, we're not multiplying or dividing by negative numbers. And we can add and subtract negative numbers all day and it doesn't bother our sign. Okay, y is greater than 2. Let me throw my little 0 on here. Let me throw my 2 on here. Greater than is open because it doesn't include 2. And greater than goes towards bigger numbers, positive numbers. Here's a little trick. As long as you're, let me change my color to show you my little trick. As long as your variable's on the left side, this will always point you which way to go, like an arrow. So it'll say go to the right. But that only works if your variable's on the left side. All right, let's do another one. Let's subtract 7 to both sides. Just like if we were doing an equation. And if you want to learn, if you don't remember how to do 2, 3-step, multi-step equations, go check out my other videos. I'm going to subtract this. And I end up with 8 minus 7 is 1. Now, I have to unconnect this. It's being multiplied. The opposite of multiplication is division. Just like here, the opposite of addition was subtraction. And I had to do it to both sides of the inequality. I'm still trying to keep it balanced. I'm still trying to balanced as in keeping this a true statement. I can't cheat and move things around without following the rules. So I'm going to divide 2 to both sides. And W, 2 divided by 2 is 1. It's gone. And W is greater than or equal to 1/2. Oh no, 1/2. What are we going to do? Well, I'm going to start with putting my 0 on here. Whenever I have fractions, I like to put a 1 on there. Remember, all proper fractions live between 0 and 1. They live in this world right here. 1/2's the easy one. It's right in the middle. 1/2. Okay, so now I know where 1/2 is, and now let's follow the rules. W is greater than or equal to, because I had that equal sign, I get to put a point and fill it in. It's greater than or equal to, and greater than goes towards larger numbers. Like I said, if the variable's on the left, this is like my little arrow pointing me which way to go. All right, number 3. This is a weird one. It looks like a distributed property problem where I should distribute and then do some steps, but I'm going to think on my feet and I'm going to say, hey, this is multiplication. Opposite of multiplying is dividing. How about I just divide this out of here? I'm not feeling distributed property today, and I don't think I have to do it. This would leave me x plus 4 here. Less than, I didn't multiply or divide by negative, so I'm leaving my sign exactly as it is. 49 divided by 7 is 7. Remember, 7 times 7 is 49. Let's subtract this 4 out of here. X is less than 7 minus 4 is 3. X is less than 3. I'm going to throw a 0 on here. I'm going to throw a 3 on here. X is less than 3. Open circle. And less than. And my point should definitely be on the line. I'm just running out of space here. Oh, what am I doing? Why am I filling it in? No way. This is an open circle. It's less than 3. It cannot include 3. Don't fill it in. You only fill it in if you have an equal sign. All right. Let's do a quote-unquote real-world problem. So, Mom sends Young into the store and says, hey, I need you to go to the store for me. First of all, I need you to buy me the biggest, it's a very special party. We're having, special people are coming over. I want you to buy the biggest loaf of bread that you can. Make sure it's not green. And then I want you to buy as many T-bone steaks as you can. Those are the ones that has a bone in it that looks like a T. I'm like, okay. Here, I'm going to give you $80. Wow, that's a lot of money. Well, these days, $80, maybe not so much, but I want you to buy one giant loaf of bread and as many T-bone steaks as you can. I'm like, all right. I have $80. That's all I have. That's the most I can spend. When we're dealing with inequalities, sometimes we have to think about the words to know, is it a less than? Is it a greater than? It's a little blurry, sorry, but okay. So I have $80. I can spend $80, but that's the most. That's the most I can spend. So at most, I can spend $80. So I'm going to use the less than or equal to sign. If I had to spend less than $80, then I would maybe use the less than sign as it's less than or below $80. But in this case, I can use the less than or equal to sign. Okay, so I need to write an inequality. So it's less than or equal to $80. That's the most that I can spend. I go to the store. All right. I go to the store and I find out the biggest loaf of bread that they have is a giant loaf of bread and it's $8. I go over to the steak section and, oh, lucky day. They're not selling by the pound. They're selling by the each. And each T-bone steak is $8. So $8 times, I don't know how many steaks, plus the $8 that I'm going to spend on the bread. Now, there's a lot of eights in this problem, isn't there? Hey, real life doesn't make numbers easy or difficult, or it's whatever numbers you deal with, you got to deal with them. So $8 per steak, and so I want to see how many steaks can I get, and $8 for the giant loaf of bread. I'm going to solve for s. So I'm going to clear this 8 out of here to the other side, giving me 8s is less than or equal to 72. I'm going to divide this 8. Luckily, non-prepared food, there's no tax, sales tax on it. 72 divided by 8 is 9. If you live in a place that doesn't have sales tax, we pay a little percentage on everything that we buy that's not grocery items. Everything else, pretty much, just about everything else, we pay a percentage up to almost 10% some places. Okay, s is less than or equal to 9. So I can buy up to 9 steaks. Let's graph it. Here's a 0. Here's a 9. Less than or equal to means I get to fill it in, and it's less than or equal to. So I could buy 1, 2, 3, 4, 5, 6, 7, or 8 steaks. They don't sell half steaks. But Mummy said buy as many as you can. So if I buy 9 steaks times $8, that's 72, plus the $8 giant loaf of bread, that's $80 total. I did what I was supposed to do. Yay me. Okay, if you pause the video here, it's your turn to practice some problems. We'll go over the answers in a minute. All right, welcome back. Let's get to solving. I'm going to isolate the variable. I want x by itself. So I'm going to subtract this 2 to both sides, leaving me 8x is less than 3 minus 2 is 1. Okay, so I subtracted 2 to both sides, and now I'm going to divide this 8 out of here. Divide by 8, divide by 8. Fraction. Okay, so let's see. So I have a 0. Remember, fractions are proper fractions where the numerator is smaller than the denominator. They live between 0 and 1. Now 1/8, if I were to separate this up into 8 little parts, so 1/2 would be about right here, 1/4 would be about right there, so 1/8 would be about right there. Not a very nice problem, huh? Open, and it's less than. So. All right. If you were able to get to the 1/8, but you stumbled a little bit on the graph, that's okay. And I better draw in that is 1/8. All right. Next problem. Let's add 3 to both sides. Opposite of subtraction is addition. I'm going to add 3 over here. That cancels. And 3 minus 2 is 1. When you have positive negative, you just subtract the two numbers and you keep the sign of the larger number. X is greater than 1. Let's throw a 0 on here and a 1, and greater than is open. And as long as my variable is on the left side, it points to me which way to go. All right, my variable's on the wrong side. Let's add 2 over here. That's gone. And I'm left with 8 is less than or equal to, I'm reading left to right, x. Reading this way, x greater than or equal to 8. I could flip this around, but I have to be very careful. The large side's opening towards the x. I have to keep the large side opening towards the x. The pointy side's pointing at the 8. I have to keep it pointing at the 8, and I can do it like that. I like to do that so I don't mess up my graph. Greater than or equal to means I put a point and I get to fill it in. And my arrow goes that way. Very nice. All right, variables on both sides. Let's drag this whole term. This whole term here is positive, and I'm going to do the opposite and subtract and just drag the entire term over to its pal on the other side in the x family. 3 minus 2x is 1x. X is greater than or equal to 4. X is greater than or equal to 4. I get to fill it in because it has a little equal sign underneath, and I get to go greater than. Now, if any of these problems had turned out negative, I would have just gone over to the negative side of things. For example, if it was x is less than negative 1, I would have just drawn my 0, gone down into negative land, open circle, less than, to the left. Notice, this is pointing to the left. Because my variable's on the left side, I'm allowed to use that little trick. Well, I hope you learned something today. Thank you for joining us. Have a wonderful day.